All the participants, good evening. We are starting the lecture now. On behalf of the IEEE Uttar Pradesh section and IEEE Young Professionals Affinity Group Uttar Pradesh section, I welcome you all in this series of professional lecture series and technical lecture series that is supported and sponsored by IEEE Uttar Pradesh section, IEEE Young Professionals Region 10, IEEE Region 10, and Upskills 2023. In today's lecture, we feel very privileged to have Dr. Satish Kumar Singh, a renowned academician, as an expert speaker, who will be delivering the lecture on fairness, accuracy, and transparency issues in artificial intelligence system. Before starting the lecture, I would like to introduce Dr. Satish Kumar Singh to the audience. Dr. Satish Kumar Singh is with the Indian Institute of Information Technology at the Department of Information Technology from 2013. Before joining the IIIT Allahabad, he served the Department of Electronics and Communication Engineering, JP University of Engineering and Technology, Guna, India, from 2005 to 2012. He has about 16 plus years professional experience in various capacities. His areas of interest include image processing, computer vision, biometric, deep learning, and pattern recognition. Presently, he is heading the Computer Vision and Biometric Lab CVBL at IIIT Allahabad from 2015 onwards. His group is involved in the R&D of the signal and image processing, vision, and biometrics algorithm and systems. He has supervised 6 PhDs and 34 master's students in his research career, and presently 9 PhDs and 6 master's students are doing research in his lab. Dr. Singh and his group has published more than 60 research papers in various IEEE, ACM transactions, journals, and international conferences of repute. He is the co-principal investigator of many projects funded from various government funding agencies such as Ministry of Defense, Ministry of Education, and Home Affairs, Government of India. Dr. Singh is holding the responsibility as local coordinator, Global Initiative Academics Network by MO, Government of India. Nodal Officer, Scheme for Promotion of Academics and Research Collaboration, Ministry of Human Resource and Development, Government of India. Convener, Departmental Postgraduate Committee and Associate Dean in charge, Ranking and Accreditation. Dr. Singh is also involved in academics and research outreach activities and presently serving as Associate Editor of IET Image Processing, Associate Editor of International Journal of Pattern Recognition and Artificial Intelligence, Lead Guest Editor of Special Issues of Springer's Neural Computations and Applications on Computer Vision and Image Processing, Guest Editor of Special Issues of Springer's Nature Computer Science on Recent Trends in Computer Vision, and Guest Editor of Special Issues of Springer's Nature Computer Science on Progress in Image Processing. Dr. Singh is proactively offering his volunteer services to IEEE for the last many years in various capacities. He is the senior member of IEEE Signal Processing Society, IEEE Computational Intelligence Society, IEEE Education Society, IEEE Photonics Society, and IEEE Sensor Council. Presently, Dr. Singh is the section chair, IEEE Uttar Pradesh section since 2021, and a member of IEEE India Council for the year 2021. He also served as the Vice Chair, Operations, Outreach and Strategic Planning of IEEE India Council in the year 2020 and Vice Chair of IEEE Uttar Pradesh section from 2019 to 2020. Prior to that, Dr. Singh was the Secretary IEEE UP section for the year 2017 and 18, Treasurer IEEE Uttar Pradesh section for the year 2016 and 17, Joint Secretary IEEE UP section for the year 2015, and Convener for the Web and Newsletters Committee 2014 and 2015. Dr. Singh is instrumental in successfully organizing the IEEE UP Sections Conference UPCon in 2015 as conference coordinator, IEEE Computer Society India Symposium 2017, and IEEE India Council AISY-WC 2017. Dr. Singh was the conference chair for the third IEEE CICT 2019 and the general chair for the fourth IEEE TS conference CICT 2020 and the eighth IEEE UPCon 2021. Dr. Satish Singh is also the reviewer of many reputed IEEE and ACM transactions. So today we feel very privileged to welcome you, sir, for this lecture. Over to you, sir.
Thank you, Varun. And thank you all for joining this particular session under the YP of IEEE Uttar Pradesh section. So my voice is clear? Varun?
Yes, sir. It is audible,
Okay.
sir.
So can you see my screen?
Yes, sir. The screen is also visible, sir.
Okay. So now, presentation.
Yes, sir. Biasness and fairness worth considering in AI.
Okay.
It is visible, sir.
Yes, thank you. So thank you, Varun, for introducing me. And this particular lecture series is under the Young Professionals Upskill Program, which has been sponsored by IEEE YPMGA itself. And Dr. Varun is the chairperson of IEEE Young Professionals, IEEE Uttar Pradesh section. So thank you all for joining this session on Sunday. Normally on Sunday, we are quite relaxed and we utilize this time for our own purposes. But here we are just to discuss about something about some non-conventional issues, like we know very well about the AI, ML, DL systems, but this particular talk focuses on some non-conventional issues which are very important while designing these AI systems for various applications in national context. The first one is as already disclosed, the topic of the talk is biasness and fairness worth considering in AI. Means these two terms are very important while designing any AI system. So entire discussion will revolve around these two words, biasness and fairness in AI systems. So disclaimer, the material used in this document has been taken from different sources explicitly for the use of non-commercial and academic use. The authors of this material do not claim for any copyright. The copyrights are with the original contributors. The authors have tried to cite the sources appropriately mentioned in the last, if missed so. So we know very well this is typical educational structure in India. Basically, at central level, there are 25 IIITs. Out of these 25 IIITs, 20 are PPP and 5 are CFTI. So IIIT Allahabad is among one of the 5 centrally funded IIITs. So this is just a glimpse of IIIT Allahabad. So this picture has been taken from the top of Boys Hostel 5, and normally it is quite soothing just after this, this rainy season. So IIIT Allahabad very quickly was established in 1999 as a center of excellence, then deemed university, then Institute of National Importance by the Act of Parliament, and now there is a separate act for IIIT. IIIT is running programs BTech, MTech, PhD. 4 departments are there: IT, Electronics, Applied Science, and Management Studies. So there are 28 faculty. There were 28 faculty members few days back in the Department of Information Technology and the research, where there are various research labs in the Department of IT, like computer vision, biometrics lab, deep learning lab, machine learning optimization, speech, image, and language processing, interactive technologies, and multimedia research lab, network security and cryptography, and many more such labs are there in IIT. The vision and mission, I mean, very quickly, we know this is very general mission and vision of IIIT, but in the domain of IT and allied areas, the Computer Vision and Biometrics Lab is having certain vision to promote learning and system development in the field of computer vision and biometrics, to become accustomed in the field through formal interactions with the experts of the domain, to execute the research projects funded from government and private sectors, to tackle the real world problems in the field. I mean, I'm just taking some time to just to make you aware about this Computer Vision and Biometrics Lab where I am associated. And the next one is to develop the international national collaboration to generate and train the manpower in the field to cater the need of the society. And these are various research fields: CV, biometrics, image processing, machine learning, deep learning. These are the group members. So there are five faculty members involved in computer vision and biometrics lab. And we are receiving funding from various sources like IIIT, Ministry of Education, DRDO, DST, SERB, NVIDIA, Gita, ISRO, and SPS, and many other sources. We are having these international collaborations with various universities, and very recently we just established the connection with the University of South Dakota as well, USA. And these are our industrial collaborators like Secure Mantra and Spine. From this lab, 10 PhD students already graduated, and couple of PhD students are still doing their research against their PhD registrations. So there are various projects. So this is something about the Computer Vision and Biometrics Lab where we are involved. So some of faculty members from CVL are also joining. I have already joined this particular discussion, like Anjali Gautam is there, whom I could mark. So let's start this discussion very formally. So what is the need to discuss this particular topic, biasness and fairness issues in AI? So why AI-based algorithmic decision systems? What is the need? It means what is the purpose? Why AI systems are, or why AI algorithms are used very extensively in decision making, almost all the domains of science and technology nowadays, because AI neither tired nor bored can work 24/7. Its widespread use of AI system, exploding AI space with full of growing applications, AI penetrating the sensitive areas of life and affecting the humans. Decision-making AI, identity establishment AI, criminal investigation AI, mission-critical AI assisted system, social media AI, recommender AI, loan and banking AI, dating and hiring AI, many more AIs. So wherever you can think, everywhere AI, AI, AI. So nowadays AI is pervasive. So every domain, every uh, nook and corner of the life is just captured by AI. If it is not, will be in coming 5 to 10 years. So AI-based algorithmic systems may be biased. I mean, although we are having so many applications, huge variety of applications of AI, but AI-based algorithmic systems may be biased, rendering unfair decisions. So if we talk about the unfair decision, then how this unfairness is just uh, capturing the decision making by the AI system. So before moving to that, we should understand about the biasness and fairness. So the absence of any prejudice or favoritism towards an individual or group based on their inherent or acquired characteristic. Okay. So unfair algorithm throw skewed decisions toward a particular group of people. Hence, these are not uniform. We have taken one example, that is the COMPAS, that is Correctional Offender Management Profiling for Alternative Sanction. So basically, this system was used to establish, whether the person is guilty or not guilty, kind of thing. It means some sort of decision making by the judges. So in US, the parole decisions are made by judges using COMPAS system. So this is an AI-based system. So it measures the risk of person to recommit another crime. For example, in the past, he might have or might not have committed the crime, but what is the risk of a person to recommit another crime. Okay. So African American offenders in general assigned with higher risk scores than the Caucasian with same profile. Everything is same except the race. And in this case, this is negatively affecting the African American people compared to the other people. It means it was giving, this is a real life example, and it was giving some sort of biased decision while deciding the parole, whether it should be granted or not. So AI system judging beauty pageant winners was biased against darker skinned contestants. This is another example. So facial recognition software in digital cameras that over predicts Asian as blinking. So normally, if this camera is just looking at some Asian face, so it just throws so many times blinking, blinking, blinking. Fairness, the discriminatory behavior affected the algorithm to deliver advertisements in gender-neutral manner for promoting jobs in science, technology, engineering, and maths. So basically, the purpose was simply to have some gender-neutral decisions. But what were the observations in this different case? Less women compared to men saw the advertisement due to gender imbalance. Okay, what happened? You have floated some advertisement for any job on LinkedIn or Facebook. Okay, so what happened? This advertisement was shown, maybe shown to women or maybe men or maybe boys or girls of a particular group or age group. Okay, it means uniformly it is not shown to everybody. Okay, so these kind of observations. So younger women being considered as a valuable subgroup and more expensive to show the advertisement. It means the algorithm was designed in such a way so that it was just means catching the younger people to show the advertisement, and advertisement cost was higher and higher. So completely discriminatory despite being gender neutral. They claim to be gender neutral, but it was completely discriminatory in behavior. Similarly, many facial recognition and recommender systems are also found to be discriminative towards certain population and subgroups. And the issue becomes more serious when application having a direct effect in our lives and can harm our society if not designed and engineered correctly, that is with consideration of fairness. It means for the mission critical systems or life systems where the AI is used to make certain decision or augment the human decisions, in that case it becomes more serious in nature. Examples in courts to assess the probability that the defendant recommits a crime. It is used in different medical fields, in childhood welfare systems, in autonomous vehicles, and many more such applications like defense. So biasness and fairness in context to data, algorithm, and end users. So if we talk about the biasness and fairness, it is not only related with the data or the algorithm or the end user, but in toto, it is very much correlated with the data algorithm and end user. And there is a cyclic effect of data algorithm and end user while considering a biasness and fairness. So training data containing biases will result the trained algorithm will learn these biases and reflect them into their predictions. It means if the algorithms are learning from the biased data, obviously their decisions will be biased. Okay. So as a result, the algorithms using the biased data may produce biased outcomes, can even amplify and tune existing biases in the data. Okay. And algorithms themselves can throw biased behavior due to certain design choices, even if the data itself is not biased. Sometimes it's possible that data is quite okay, but algorithm at the time of designing the algorithm, okay, we left some parameters which were really very important. In that case also, biased behavior may be thrown by the algorithms itself. So as a result of algorithmic biases may affect users' decision, okay, causing more biased data for training in future. Okay, because sometimes it's possible on the basis of the decisions by the algorithms, data is labeled, okay, or decisions are made by the users. And if these decisions are again fed to the data side, then the biasness will amplify. We have taken one example of search engine. Most interactions with top ranked resulting little attention to the items down the list. What happens? Suppose we are making a Google search. So at the top, we get some results at the top. So normally, what is the practice? We click the top ranked result, means the result which is coming at the top. We do not bother whether this top ranked result is having some useful data or useful information or not, or some contextual. So algorithms relying on their user interaction with the thrown items, popularity and user interest will affect the future decisions, obviously. If more number of users are clicking that particular link, then it will come at the top, and one day everybody will click that particular link. So items at the top will become more and more popular. So not because of the nature of the result, but due to biased interaction and placement of result by these algorithms. It means if we study about the Google's page rank algorithm, and if it's not taking care of the fairness issues, then sometimes it's quite difficult. I mean, there are so many search engines. Every search engine is having its own algorithm in the backend. So we should test which algorithm is bias free or quite fair compared to the others. But it happens in practice. So data is related to the algorithm, and algorithm affects the end user. End user, whatever gets the output, again produces the data. So if the data itself is biased, algorithm will learn wrongly from the biased data, will throw the biased result. End user will get the biased result, and then again biased data will be produced. So this is simple cyclic effect. So in loop dependence, so there is a dependence between the data algorithm and end users in cyclic manner. So end user to data, because end user used to produce the data on the basis of the past experience. So some sort of bias is introduced in the system, and this bias is simply known as a content production bias or behavioral bias. Similarly, data to algorithm, because every algorithm is fed with some data, and this kind of biasness is simply known as aggregation bias, simply known as longitudinal data policy or aggregation bias, and algorithm to end user, emergent bias. So you can just observe that data, algorithm, and end users are not independent to each other. All these are related. And obviously, in loop dependence is present, and that's why this is the biggest reason of non-correct or biased behavior of those systems. Let's discuss about some data biases. So what are the examples of the data biases? Like measurement or reporting bias. What is this bias? This depends upon how to choose, utilize, and measure the features. Okay, so this is very simple. Suppose you have to classify the fishes. Okay, and there are two classes of fishes. One class of the average height of or average length of a fish is 50 centimeter, and in another case, average length of the fish is only 10 centimeter or 5 centimeter. And if you measure in the centimeters, what will happen? One is 50, second one will come in the range of 5, 6, 7. Another is 50, 60, 70, 40. Okay, so obviously this will be, I mean, this type of measurement will be biased towards the class 1 kind of fish. So this is very important. The recidivism risk prediction via compass, like these were the observations prior. I mean, why compass decision were biased basically. So some observations were made by the researchers, like prior arrest and family arrest were used as proxy variables. Means the system was using these variables, like whether the person was arrested prior or before, or any person in his family or friend was arrested before. So these were some measures, some parameters which were used to train the system. So basically, this is not fair, basically. Okay, so prior arrest and friend family arrest were used as proxy variables to measure level of riskiness or crime, which on its own can be viewed as mismeasured proxies. Okay. Factually, the minority communities are controlled and policed more frequently, resulting in the higher arrest rates. For example, there is a crowd, okay, in US. So if these are dark-skinned people, so there were chances to arrest those dark-skinned people just for some precautions. Those people never committed any crime, but still those were arrested for some time. Okay, so what happened in past history? All those arrests were recorded against those dark-skinned people. So those parameters were used. So that these were the major reasons why that compass was throwing some biased behavior towards the dark-skinned or African American people. So in this case, are minority groups more dangerous? We cannot say, we cannot confer, or we cannot infer that the minority groups are more dangerous, because in most of the cases there may be that some friend committed some crime, or the person itself was just arrested due to some other reason. He never committed any crime but was arrested because he or she was dark skinned person. Okay, there may be the case of immediate variable biases, like when one or more important variable are left out. A highly accurate model to predicting the annual percentage drop rate from subscription based services, like this particular example was taken, and many people were leaving these services. So what were the observations? At the time of design, everything was okay, means all the data and everything, how data was collected and this data was fed to train the algorithm, everything was perfect. Then what happened in this case? Suddenly majority of users are canceling the subscription. Okay, reason is simply the emergence of new strong competitor offering the same on half price. It means at the time of design this was never considered. Means the price of the component was never considered while creating the data. Okay, so while designing the model, the possible emergence was just omitted and some bias was created in the system. Another is the representation bias. So as the name itself, it deals about the representation, means how one class is being accumulated in the entire data. So representation bias depends upon how to sample from population during data collection process. What is the issue? Non-representative samples lack the diversity with missing subgroups and other anomalies. Like here in Indian context, if we collect the facial data from Kashmir to Kanyakumari, then what happens? Or similarly, the northeast extreme point to the Gujarat's extreme point, then what will happen? There is huge diversity in terms of the shape, in terms of the color, in terms of the texture. Got it? So if we have not collected the data from throughout the India, suppose we have just left the northeast people, then what will happen? We have designed the excellent facial recognition system, but due to this representation bias, may not work well in case of the northeast people, or vice versa. So data sets like ImageNet results in demonstrable bias towards Western culture. So this was the data. Here, the data distribution, we can see the distribution. So maximum contribution in this ImageNet and other open image data were from US, then Britain, and then other countries. Got it? It means most of the persons were from US or Britain or European countries. Very less or almost nil data from Chinese or maybe from Indian. Okay, so what will happen? Although the algorithms were excellent, but sometimes these algorithms will fail in Indian context or will throw some wrong decisions. So this is the demographic distribution in the ImageNet data set. So maximum data is coming from these regions, okay, the darkest region. And as the shade is lighter and lighter, the contribution is lesser and lesser in the data set. So let us understand something more about the aggregation bias. So aggregation bias depends upon the false conclusion drawn about individuals from observing the entire population. What happens? We have collected, suppose we are just predicting the knee joint, means we are okay. And what happened, we collected the data from entire India. We collected the data entire India, or you just consider a scenario where we collected the data from Uttarakhand, Himachal Pradesh, and Northeast hilly areas, and some portion of the Madhya Pradesh or Uttar Pradesh, some planar region. Totally hilly area and planar region. The algorithms will be trained on these data. Okay, what will happen? If the data is mostly collected from the hilly region, okay, then considering a similar situation, the knee joint predictions, disease predictions will be lower. Actually, isn't it? For example, at the time of testing, planar people were considered whether this person will be prone to have the knee joint disease in future or not. So obviously, the algorithm will throw lesser chances of the knee joint prediction, disease. Why? Because hilly persons are more robust towards these knee joint diseases. Okay. So in toto, the algorithm's accuracy will be excellent. It means if we collect 50% of the data from the hilly area and 50% of the data from non-hilly area, then everything is fine. Means the accuracy will be excellent. But if we test on, if separately we test, then what will happen? The accuracy will be very high in case of the hilly area, but very low in case of the non-hilly area. So this is the case of the aggregation. Means we are considering the collective features or collective representation for a particular individual. Okay, so this is the case. So consider the diabetes patients. The HbA1c level differs in complex way across gender and ethnicities. This is one more thing. Suppose some some benchmark has been created, some fixed value has been created that above this level, it will be very highly diabetic or not. Okay, but this is basically relative term. So a model ignoring the individual differences is likely not well suited for all ethnic and gender groups in general, despite no reorientation bias. It means it is not necessary that the level which were set for the American people or the British people will work for the Indian people as well. Okay. So any general assumptions about subgroup within the population can result in aggregation bias. It means in general for entire population, the assumption may be true, but for a particular person, this assumption may not be applicable. And that's why a result may not be true for that particular person due to aggregation bias. Similarly, there is Simpson paradox. This is very important. So Simpson paradox arises during heterogeneous data analysis. What is heterogeneous data? Means we have collected huge variety of data. Means suppose this is a facial data, all age groups, all demographic locations, all genders. Okay, if we collect this kind of data, this is really heterogeneous data. Not only that, all sort of variations are possible in this heterogeneous data, like occlusion, the scale, the distance, every kind of variation. Then only it will be treated as the real heterogeneous data. So Simpson paradox arises while using the heterogeneous data. So nature observed in aggregated data disappears or reverses when the same data is disaggregated into its underlying subgroups. So gender bias lawsuit in university admission against this example, US Berkeley, as it seemed like there was bias towards women, a smaller fraction of whom were being admitted to graduate program compared to their male counterparts. So this was observation that very less number of women were admitted compared to the males. So people thought, okay, this decision making is quite biased, and biasing is adversely affecting the females. So admission data analysis over the departments revealed women applicants had equality and in some cases even a small advantage over males. This was the case. Then how this decision making was just throwing the decisions and was considered as the biased decision? What was the effect? What was the reason? Then why it happened? So the reason was simple, that female tended to apply to departments with lower admission rates for both genders. Got it? Say 50,000 women applied, and out of those 50,000, 40,000 women applied to department A, where number of seats were very less or the admission rate was very less. So what will happen? Out of 40,000, 40 women and one male was selected. But in other departments, males applied and the admission rate was quite high. So what happened? If we consider department wise, okay, department wise, there was no problem, but in toto there were issues. So Simpson paradox has been observed in a variety of domains, including biology, psychology, astronomy, and computational social science. So this is very important bias. Then the sampling bias, like representation bias, due to non-random sampling of subgroups. Okay, we have selected some persons. Okay, for example, we are just developing a facial recognition system, and in a village there were 100 families. Okay, and in every family there were 6 persons, so 600 people were there, and we were supposed to collect the data of 100 people only. Okay, then what happens? 6 so total means approximately 17. Okay, 17. If data is collected from only 17 families, then we will collect data of 100 faces. But what will happen? What will happen? Because there will, all those facial data will be quite common. Means all 6 persons may be having some sort of similarity. Maybe there were 4 brothers in a family and all 4 brothers were looking alike or very, very similar. So what will happen? Rather than using a random sampling, we have used non-random sampling of subgroups, and sampling bias will be created. Okay. The trends estimated for one population may not generalize to data collected from a new population if the sampling bias exists. Another is the linking bias. When network attributes obtained from user connections, activities, or interactions differ and misrepresent the true behavior of the users. Okay, we have analyzed, or we have just captured for one kind of network, and we have trained the model. It is not true that it will act, or it will act in the same manner as it was acting previously. So social network can be biased towards low degree nodes, yes, when not considering the content and behavior of users in the network. So user interactions are significantly different from social link patterns that are based on features such as methods of interaction or time. Okay, means it is not necessary. Suppose there is a social network, okay, one network, and one person is connected in one network. Second, I mean, you just consider the WhatsApp groups. Okay, so I'm connected in the WhatsApp group of my friends. So all are aged between 40 to 48, suppose. And I'm also connected in a network where the students are there. Means in the range of 18, okay, to 43, 44. So this is another network. But what will happen? I used to post. It is quite possible. I will post many messages in one network, but I will not post the message in another network. Because in the friends network, I may feel quite relaxed, but in case of the students network, I may feel myself, quite constrained. So I am the same, okay, but you cannot assume that I am going to throw many messages in all the WhatsApp groups. Okay, so this is kind of linking bias. We have just assumed. There is another bias, longitudinal data fallacy. So that is temporal data must use longitudinal analysis to track cohort over time to learn their behavior. Okay. Instead of temporal data is often modeled using cross-sectional analysis, which combines diverse cohort at single time point. Okay. The heterogeneous cohort can bias cross-sectional analysis, leading to different conclusions than longitudinal analysis. So, what was the example? Bulk Reddit data analysis revealed that comment length decrease over time on average. Means people are just using smaller and smaller comments. This is a general observation from the entire data. But was it true or not? So after analysis. So however, bulk data represented a cross-sectional snapshot of the population, which contained different cohorts who joined Reddit in different years. Okay, people joined the Reddit in different years. When data was disaggregated by cohort, the common length within each cohort was found to increase over time. Okay, it means the younger people were using bigger comments. But in total, means when using earlier methods, the general observation was that comment length is decreasing, but actually the comment length was increasing cohort wise. So these are simple data biases like longitudinal data fallacy, linking bias, sampling bias, Simpson paradox, okay, aggregation bias, demographic biases or representation biases, omitted variable bias, okay, measurement or reporting bias. So all these biases means we just discuss about these biases. So we should consider while designing the AI system, machine learning or deep learning system, ever we considered these kind of biases at the time of designing the system. So normally we are just designing the system, but all those biases are omitted. Only some sort of representation or other biases are considered. Then this was all about the data biases. Now let's discuss something about the algorithmic biases. Means algorithm itself can take the biased decisions or can learn in totally biased manner despite the best kind of unbiased data. So bias is not present in input data, rather added purely by the algorithm. This is also possible. And what is the reason? The algorithmic design choice is responsible for biased behavior, such as use of certain optimization functions. Okay, you're having choice of many optimization function, but some optimization functions may produce some biased results. Some regularization techniques, variety of possibilities, some may produce the biased results or biased learning. Choices in applying regression model on the data as a whole or considering subgroups. How you're applying the data. How you're using the data. The general use of statistically biased estimators in algorithms. So all those reasons are for biased algorithmic designs. So suppose you need to test whether your algorithm is biased or bias free. Then you need to use various optimizers and then test on each and every algorithms. Means do the testing of fairness for each and every optimizer and then check that the results are similar for the entire population. Means all class of data. And that should be true with the optimizer, the regularizer or regression model or the classifiers. Everywhere. Means same sort of results should be displayed. Then only you can say that your algorithm is unbiased or fair. User interaction bias may appear through the user interface and through the user itself by imposing his self-selected bias behavior and interaction. Okay, means user itself may be biased. I mean, for or against the decision by the algorithms. Classes of such biases are presentation bias, how information is presented. Okay, web users can only click on content that they see. What is there? User interaction bias means there is Google's page rank algorithm. Okay, and this page rank algorithm is providing the ranking to the web or the URLs which are read or clicked maximally. Okay, this is one parameter. And what is happening? Actually, what is happening? So what is happening? We are using the computers and just searching something on Google. What happened? We generally click on the web pages which are actually shown to us. We never go to the second page, third page, fourth page, fifth page, or 10th page. But it is not necessary that all the time the best information will available on the first page. Sometimes it is possible that the most useful information is available at the last page, or most contextual information or most appropriate information is available at the last page. So what is happening? We are just clicking the URLs which are just appearing on the first page because other URLs are not shown to us or not presented to us. So this is kind of presentation bias. Ranking bias, the idea that the top ranked results are the most relevant and important will result in attraction of more clicks than others. The first one is the presentation bias, means we can click any URL which is displayed on the first page or on the screen, will have more chance to be clicked. The second thing, ranking bias, the top ranked URL will be having the best chance to be clicked. Okay, so this is the ranking bias. So presentation bias and ranking biases are the examples of the user interaction biases. So algorithms are learning, okay, in this way. So that's why the algorithm itself may be biased. Popularity bias, items that are more popular tend to be exposed more. Okay, this is another kind of bias. So popularity is subject to manipulations. Example, fake reviews or social bots, search engines or recommendation systems. So if you are relying on any recommender system, then you should know whether it is affected by the popularity bias or not. If it is free from popularity bias, then only you can get the best results out of these kind of recommender systems or recommender algorithms. So popular objects would be presented more to the public, but this may not be a result of good quality. Instead, it may be due to other biased factors. So evaluation bias. Again, let's discuss about the evaluation bias. So during model evaluation, okay, use of inappropriate and disappropriate, okay, benchmarks for evaluation of applications. Means we are using the data, different kind of benchmark data, which is actually not appropriate for that particular application. Okay, so can you give me one example? Suppose we have to design the facial recognition system, okay, and we are evaluating this model on ImageNet data. Okay, so this is a kind of object classification or data, basically different classes of the images. So image classification, and image classification is used for the facial classification. It may not work at the time of facial recognition. So examples, ADDIANS and IJBA benchmarks used in the evaluation of gender classification and facial recognition were biased toward skin color, minority subgroups, and gender. It means how we are going to assess the algorithm itself or evaluate the algorithm. Okay, so that also produces some sort of bias in the algorithm itself. The third class of the bias is the user biases. So data has been produced by the users, whether it will be biased or unbiased, means clean or biased. Algorithms may be clean or biased. At the end, the users come in the picture. So users may be biased or unbiased. So majorly data to train machine learning models are user generated, with some inherent biases to be reflected in generated data. And these biases, please understand, these biases may be intentional or unintentional. Okay. Suppose I say I need to design a facial recognition system and you collect the data from only 10 families. Then what will happen? Unintentionally, this is the biased data. Okay. So if this kind of data is produced by the users, okay, and you have tested on those 10 families only, then obviously your results will be good. And you will produce more and more such data. And you will consider that you are producing the best data, but it's not actually. So biases present in algorithm might affect or modulate the user behavior, okay, which may cause to bias in the data generation process. Kaise? Suppose algorithm was biased, okay, and non-appropriate URL was thrown at the top, every time top. So what will happen? User will understand that this is the best URL, okay, and will next time may treat this URL as the most appropriate URL to train the different model. Okay, so it means the user is biased by the algorithmic decisions, which were actually biased in nature. So obviously the users will produce the biased data. Okay, and this biased data will certainly affect the algorithm to throw the biased result, and again other users will get the biased outcomes. So example, in 2018, image-based searching for CEOs resulted in fewer female CEOs images. Means somebody was searching, means people started searching for some CEOs, okay, and images of almost many CEOs were stored in the system. Since only 5% of the Fortune 500 CEOs were women. So this was a real scenario. Only 5% of Fortune 500 CEOs were women, which would cause the search result to be biased towards male CEOs. Every time more male CEOs were coming. So this was the example of historical bias affecting the data generation process. Okay, it means more male CEOs will come after searching because actually female CEOs were very less. Okay. So population bias arises when statistics, demographics, representative, and user characteristics are different in the user population of platform from the original target population. Okay, this kind of population bias will arise. Okay, means you have collected data from different demographies, different races, different colored skins, and different kind of users. So population bias creates non-representative data. Okay, and again, if this is non-representative data, then it will create the non-representative data bias. So measuring the level of enthusiasm for a political candidate. Okay, so this is another example. Measuring the level of enthusiasm for a political candidate, the most enthusiastic supporters are more likely to complete the poll. So what happens? Why these political people tries to accumulate more and more people in the rallies? What is the reason behind it? If these people will participate in some sort of rally or campaigning, those people will definitely poll. Not only poll, but poll in favor of the leader. So measuring the level of enthusiasm for political candidate, the most enthusiastic supporters are more likely to complete the poll. Self-selection bias, subtype of selection or sampling bias where subjects of the research select themselves. Social bias, when others' action affect our judgment. This is very useful. Suppose all of us might have gone through some sort of selection process or some sort of interview process. So what happens? In interview, the decision of one person affects the decision of another person. If they discuss among themselves, their decisions are little biased socially. Like when influenced by others, high rating. This is example. When influenced by others, high ratings, we choose our scoring from low to high, thinking that perhaps we are being too harsh and vice versa. It means we are not relying on our own decisions, rather we are modulating our decisions on the basis of others' decision. Okay, so this kind of decision making, which is affected by the bias, and the bias is simply the social bias, which is very dangerous in interviews or selection panels. Behavioral bias. So different user behaviors across platform, context, and different data sets. So differences in emoji representations among platform can result in different reactions and behaviors from people, and sometimes even leading to communication errors. So these are some sort of behavioral biases. So people start thinking in Twitter about a particular topic. Okay, generally using a hashtag at beginning to capture attention, and after some time they do not bother to then continue the discussion without using hashtag. Okay, so temporal bias. This results in temporal bias due to differences in populations and behaviors over time. The differences in use of language across different genders, age groups, across and within countries and the population. So content production bias. So we need to consider the temporal bias. We need to consider the content production bias. Temporal bias means the Twitter users are new users or the old users. Similarly, content production bias, what is the age group, what is the gender, what is the country, what is the race, these kind of things. And every group may have different kind of content. So we have discussed about various user biases. Okay. And the algorithmic biases. User interaction, presentation, ranking, popularity, and then evaluation bias, historical bias, population bias, self-selection bias, social and behavioral biases, temporal and content production bias. These biases we have gone through, the algorithmic as well as the user biases. So we have discussed about the data biases, we have discussed about the algorithmic biases, we have discussed about the user biases. So we know about these biases. Now we must understand about the discrimination. What is the meaning of the discrimination here? Due to human prejudice and stereotyping based on the sensitive attributes, which may happen intentionally or unintentionally, and a source of unfairness. Means sometimes the protective attributes or sensitive attributes are used knowingly or unknowingly for producing the data, for designing the algorithm, or for taking the decisions. And if it happens, then certainly discrimination will be created. Bias may generate unfairness due to human prejudice and stereotyping, but without using the sensitive or protected attributes. Means discrimination and biases are having little different things. Discrimination will be produced by intentional or unintentional use of sensitive or protected attributes. But biasness may occur without the knowledge of the protected attributes. So there is a little difference. But we must know what are the sensitive attributes or the protected attributes. So these are the examples of the sensitive attributes like race, gender, color, age, disability, income band, family status, marital status, recipient of public assistance, earlier conviction and punishments, religion, nationality, and others. So these are the protected attributes. Normally, the algorithmic decision making should not be done on the basis of these things. And if you are collecting the data, okay, if you are collecting the data, then these attributes should not be visible to the algorithms. Okay. Otherwise, intentionally some sort of bias will be means decision making algorithms or systems should not take the decisions on the basis of age, color, disability, income band. Like suppose we have to award the visa and the visa rejection rate is higher in case of the dark skinned color or some country persons, okay, then obviously it is biased algorithm. It should not be affected by the age or any kind of protected attributes. But what happens? Sometimes discrimination will happen. But this is the explainable discrimination. What is explainable discrimination? Differences are justified and explained. It is not considered to be illegal discrimination. Like UCI adult data set, males on average have higher annual income than females, causing a potential unfairness against the female based on gender sensitive attribute. This may, we can consider that there is a bias. How to explain it? Because on an average, female works fewer hours than male per week. So it's legal now. If it is the case, then it's legal. So causing the reverse discrimination. So without considering working hours, such that males and females end up averaging the same income, we will lead to reverse discrimination since we would cause male employee to get lower salary than females, which is illegal and equally harmful and undesirable. Okay, so this is the case. There may be case of unexplainable discrimination. So the discrimination towards a group is unjustified and therefore considered illegal. And when it will be considered illegal? Considering the same UCI adult data set, if while predicting the employability by some machine learning method, and it comes out that males on average have a higher employability than females, causing a potential unfairness against the female based on gender sensitivity. This will be treated as a discrimination. How to explain? Not explainable, it's illegal now. So for some data set, the legality or illegality depends upon the type of decision. Which kind of decision you're taking. From the UCI adult data set, you're taking the decision on employability or you're taking the decision on the income. Income is quite fair or non-discriminatory. Income decision is non-discriminatory in behavior, but employability decision will be discriminatory in behavior. How to correct it? If this kind of illegality is present in the decision making, then what is the way to correct it? Pre-processing techniques to change the training data such that it contains no unexplainable discrimination for a particular application. It means explainability should be included in the decision making. Then no discrimination is observed or potential to observe. Okay, so that's what nowadays people started talking about, the explainable AI, because these people are trying to design non-discriminatory AI systems. So direct unfairness due to protected attribute like age, gender, race, etc. Indirect, some hidden or other attributes causing the unfairness in terms of gender, race, etc. like zip or pin code. Okay, suppose you're using the African pin code, you're not mentioning the race or gender or whatever, you're not mentioning that race, and you're using the American pin code. So obviously there is a difference, and that pin code can be used indirectly to take the decision. So this is indirect discrimination. But what is direct discrimination? Like age, gender, race. So there may be direct discrimination, there may be indirect discrimination. Both should not happen in decision making and should be explainable. So how to fight against bias and discrimination? What are the ways to fight? Since long in philosophy and psychology, but very newly considered in machine learning. So broadly, fairness is the absence of any prejudice or favoritism towards an individual or a group based on their intrinsic or acquired traits in context of decision. Okay. So fairness is highly desirable but difficult to achieve in practice. Defining the fairness is relative and hard in machine learning, but many definitions have been proposed. So if you go in detail, so there is a separate Microsoft is providing this sort of collection of the articles which talks about the fairness, accuracy, transparency in the machine learning. So you can get a lot of insight from that URL. So if we need to design the fair systems, then we need to define the fairness. So fairness can be defined as equalized odds, okay? Then equal opportunity, demographic parity, treatment equality, test fairness. Okay, so for each and everything means there are certain ways to test. Okay, whether this is following the equalized odds, equal opportunity, demographic parity, treatment equality, or test fairness or not. So you can test your algorithm, your system, whether this is fair or not. There are certain more like fairness through awareness, fairness through unawareness, counterfactual fairness, fairness in relational domain. So we should have all these 9 kind of fairness parameters. So your algorithm or your system should follow these parameters, basically fulfill the requirement in terms of these parameters. So, and these are based on the outcomes basically. Okay, all these parameters are defined on the basis of outcomes. Let's consider the first. What is the equalized odds? The protected and unprotected groups should have equal rates for true positive and false positive. Okay, protected means say we are using the gender as a protected attribute. So protected as well as unprotected, there should not be any change in the true positive and the false positive, whether we consider or not. So this is the case of equalized odds. Similarly, the others are possible. So we can define the fairness in largely in 3 groups. Number 1 is the group fairness. Treat different groups equally. This is the theme. Treat different groups equally by following 1, 2, 3, 4, and 5. What do you mean? What do you mean? Equalize odds, equal opportunity, demographic parity, treatment equality, and test fairness. Then, if these first 5 fairnesses do exist, then this is group fairness. It means different groups are treated equally if first 5 fairness criteria are met. Individual fairness, similar predictions to similar individuals if 6, 7, and 8 are met. And subgroup fairness if 9 is met. It means what happens? If all the criteria, means all the definitions are satisfied from 1 to 9, then you can achieve the group fairness, individual fairness, and subgroup fairness. And if you achieve all sort of fairness, then your system is the fair system or the best system. So fair machine learning methods in general, how it can be done? Pre-processing to transform the data to remove the underlying discrimination. Means pre-processing can be used to avoid the data biases. In processing, to modify and change state-of-the-art learning algorithm in order to remove discrimination during the model training process, either by modifying the objective function or imposing a constraint. So this is the in-processing method. And post-processing method, it means if you cannot access the data or algorithm, then you can tweak with the decision. So if the algorithm can only treat the learned model as a black box without any ability to modify the training data or learning algorithm, then only post-processing can be used, in which the labels assigned by the black box model initially get reassigned based on functions during the post-processing phase. It means you can design a fair machine learning methods either by using the pre-processing or in-processing or post-processing methods to incorporate the group fairness, the individual fairness, or subgroup fairness by fulfilling the fairness in relational domain, counterfactual fairness through unawareness, fairness through awareness, or test fairness, treatment equality, demographic parity, equal opportunity, or equalized odds. So now we need to question ourselves that at the time of designing these machine learning or deep learning models, whether we are considering these factors or not. So this is my observation that in most of the designs, okay, we are just following the traditional methods, and we are very little bothered about these kind of fairness or biasness constraints, okay, or explainability of AI systems, which are actually very much required for effective systems. And I have considered some examples like in biomedical applications, okay, means people try to improve the performance by debiasing the methods or making the models more fairer in nature. Okay, so due to lack of time, I'm just moving down, and you'll find that all mission critical life related applications, this is very, very important to develop these models, these kind of fair models rather than unbiased and fair models. So it's really a point of concern. So today's topic is really a point of concern. And since all of us are dealing with the design and development of AI systems, so we all should consider these factors as well, because these are equally important or even more important. We need to decide, and thank you so much for patient listening.
Thank you, sir. Thank you very much for the information. Any question from the participants? Any question from the participants?
So really, this topic was not very conventional. I mean, we did not discuss about any mathematics or any model, but we largely discussed about the concerns which we are going to face. And there were several examples where, even in case of biomedical applications, most of the algorithms are being developed in Europe. Okay, and these algorithms are very, very highly biased and not giving good results in Indian context, just because of those factors.
Sir, I have a question that in the context of Chat GPT, means how Chat GPT is affecting this artificial intelligence AI systems.
Actually, Chat GPT means the outcome of the Chat GPT depends upon the data which is available on the web. Okay, means already available. It's learning from the already available data. Okay, like
yes,
suppose we take an example that we need to write a good research paper on transistors. Suppose, okay. So what is happening? It's just crawling the data. I mean, we can train the Chat GPT by the articles which are already present on the web, freely available, or whatever way. And after just going through these papers, it's producing another paper. Okay. So what is happening? Again, this paper will come into the repository. Suppose means all the Chat GPT produced research papers on a particular topic will come into the repository, and next time the Chat GPT will learn from its own data. So what will happen? Eventually, you'll find that I have considered only one domain, but you consider all the domains in comprehensive manner. Then what will happen? later on we will find that this chat GPT is not going to serve the purpose. It's going to fill the entire space, maybe some useful data, but most of the garbage data. So that's why now people have devised or just doing the research to combat the chat GPT in several terms. Obviously, there will be hue and cry in almost all the domains which are related to the language, okay, or the text. Now people started generating the images in using some chat GPT and other concepts as well. But certainly, yes, in shorter time, it's going to produce hue and cry, basically. It is going to produce the chaotic situation, but later on, it will be settled. It is just a prediction. This is just personal remark.
Okay, sir. So, sir, thank you, sir. On behalf of the IEEE Young Professionals UP section and on behalf of all the participants, I once again thank you very much. And I personally thank you, sir, that you took out time from your busy schedule and that too on Sunday, sir.
Thank you, Varun. Thank you. Thank you all for joining this session. Thank you.
Thank you, sir. Thank you. Thank you, all the participants. You may now please leave the room. Thank you. Thank you once again.